Alright, ladies and gentlemen. Welcome to the KeyRipple custom character tutorial series. Before we get started, I'm going to use one episode first. Make it clear what the custom character is doing first. Specific to the operation, custom characters involve many aspects, including checking and modifying character bounds, initialize the control system, setting up the mapping of bounds and controls, set a control rig or restraint. In addition to recording the reference posture of the character, we need to collect some location information. Anyway, there are a lot of steps in between. So many steps and tasks. Sounds complicated. It's actually just 3 things. 1. Establish control system. 2. Record reference posture. 3. Collect instruments location information. Let's talk about the first thing, building the control system. To understand this, first, you need to understand how the music.do series of software works. First of all, music.do doesn't directly convert MIDI data, turned into character skeletal data. That is to say, when a character plays a music note, the software doesn't directly calculate, at this time, the fingers, elbows, or head of the character, how many degrees should these bones be rotated? Where should it be? It doesn't do this. Software actually only does one thing. Calculate the transformation of the control. So, what is a control? If we open the Blender project file, we can see that there will be a directory of add-ins in the sidebar. There is a controls directory below. Everything in there is a control. For example, this H_L left hand. There are all 1 to 3 for under the left hand, a total of 5 fingers. And the polar vectors, pole targets. And this HP_L is the polar vector of the arm, which controls the direction in which the arm is bent. The same goes for the right hand. It's just that the suffix is different. The numbers are also different. Next is characters orientation controls. They include the midpoint of both hands, looker targets, head controls. They are used to control the character's upper body. It has the same structure in the UE. In UE, we turn on the character's control rig. You can also see a control system here. Under the control root, there will be left-handed controls. There are also finger controls. Pole target control. The same goes for the right hand, just suffix is different. Then the header control. There are also looker control, mid-hand control. Although the external form is different, but the control system in the two software is exactly the same. Controls are just a few key handles attached to the character. music.do calculates every moment based on MIDI. The position and rotation of these controls in 3D space. It doesn't control the real-time position and rotation of every bone in the character, so a translation mechanism is needed. This translation mechanism is the control system seen earlier in the two software. Its function is to transfer the received control information into every bone's transformation in the character. And that leads to the actual posture of the character. In Unreal, this control system is the control rig system. We will build out this blueprint in the control rig. In the Blender, the processing method will be slightly different. We will use constraints to build our control system. On the character skeleton, we will add a lot of constraints. Mostly is IK restraint, and some rotation restraints. We combine various constraints, form a control system, turn controls transformation to the movement of the character. The second thing to do is to make reference posture of the character. What's the reference pose? When a person is playing an instrument, there are several representative postures. Other playing movements can be derived from these basic postures. You can consider them as the keyframes of the playing movements. For example, Raimu's current pose. It's the reference pose when she plays the black key in the middle position. It's the same in the Yui. It's the reference pose for playing white keys in middle position. Playing an instrument is very complex. When performers play a note in different zones, or play keys of different colors, her posture is different. But it's also regular. For example, in the high notes, then the body should be tilted towards the high notes. That's tilted to the right. Let's look at the poses for playing the high notes. The palm will also be tilted towards the high-pitched areas. And the tilt amplitude of the left and right hands is different. In addition, when playing black key or white key, pose is different. Now it's the pose playing black key. If it is a white key, characters don't need to be so advanced. She should move back a bit. This is what happens in the high notes. And then we can look at the bass area. In the bass zone, characters will face to the left. It's the exact opposite of the high notes. To calculate all the possibilities of playing, we need to collect controls data of these reference poses. It's about ergonomics. Playing habits, even if it's visually natural. So these basic poses had to be placed by our own hands to ensure they were beautiful and natural. During the entire piano performance, there are 6 positions we are going to collect. The poses are organized in 2 dimensions. The first dimension is the range of the performance. As we can see, there is a hand position menu. Left or right hand, divided into 3 categories. It's high, low, and mid. It means play in the highs, the alto, and the bass zone. The same goes for the right hand, same thing in Unreal. Here are position options. Another dimension, it's the key type, divided into 2 categories, black keys or white keys. Three types of positions, multiplied by 2 types of colors. It's 6 poses, besides the 6 poses. We also record 2 positions representing the height of the palm. We see a yellow dot on the screen, now. It means height of palm in regular performance. And here's another one. This is the height of the palm when playing expansion. I'll explain what regular performance is. What is expansion performance? Take Ryman. She's 100 range is set to 12. It means 12 semitones, equal to 1 octave. But she didn't always need the expand palm for an octave. In normal case, she only need the expand hand to 8 semitones, so she doesn't have to lower her hand. That's the normal expand height. But if she's going to play 12 semitone spans, then her palm has to press down a little bit. Then the finger can be easily opened to press an octave. This is why they expand the palm height. At this stage of recording reference pose, our task was to collect data from those 6 poses and to hand height. Collect it all. With this data, KeyRipple can read currently playing music notes, calculate interpolate between the reference poses. Finally generate controls motion information. Control system then translates these to skeletal animation, so reference posture is really important. More accurate poses you placed, then more naturally final animation will be. Okay. And then finally, there's a third thing. We need to record key geometric information of the instrument. Why we need the geometry information of an instrument? When software calculates the precise position of the control, it need know how instrument locate in 3D space. For example, Ramu play note 95 on the keyboard. Then we must tell the software, how is the entire keyboard distributed in space? Where is the 21st tone? Where is the 107th tone? Then it can figure out where the 95th key is. The piano only needs to record for key positions. Change it. Change perspective. We can see more clearly. These 4 key positions are black key position, that is, the position of the highest end of the black key. Now we see where the little yellow dot is. And then the white key for the highest note. That is, a white key at the end of the entire keyboard, the position of its end. That's where we see the yellow dot. In addition, there is the lowest white key position. It's the lowest white key on the left-hand side, but not at the end. It's on the other end, at this location. And we still have to record its other end position. This is the position of the end of the white key of the lowest note. From the top, the 4 positions are distributed like this. It looks different from the side. You will find that the black key position is higher than the other 3 positions. It's on another plane, which we call the black key plane. The other 3 positions are on the same white key plane. With these 4 key data points, we can calculate precise location of each key on the keyboard. All of this information mentioned earlier. It includes pose information, instrument location information. They will export it as a JSON file. Whether it's Blender or Unreal, there will be a recorder info export function. It will export a file with the suffix avatar. All this information will be recorded in the file. In UE, it is on this interface. Use the Export button to export the file. Besides these information, there are also some basic settings. Unreal is in the property interface. Blender is at the top of the plugin. What is this data? The first is how many fingers does the performer have? And people think that's crap. Don't all humans have 5 fingers? But when designing this software, I wasn't entirely thinking about using human to play. Maybe there is some kind of 6 fingers, even a 7-finger creature to play. So this number of fingers can be expanded. Having said that, but I haven't actually made a creature like that to play the piano. It's just a possibility of this expansion. Next is how many semitones can be covered by one hand. Is the hand range? Next, that's the leftist position, middle left position, and mid right position, right position and rightist position. They are all middle finger key values. When hands in a 3 position, total of 6 positions. When we have the character play in the middle, then the key corresponding to the character's left middle finger, it's mid-left position. Now Ramu's left middle finger is on the 52nd key. The position of the right middle finger is the mid-right position. That's 76 if she is playing in a high position. Right middle finger is at rightest position. At the same time, the left hand is at far right position as it can reach. This is right position. The name is really a bit confusing, but I've already written it like this, and I'm too lazy to change it. Okay, so the other end, we change the position to the low zone. The position of the left middle finger is the leftist position. The current position of the right middle finger is the left position. Contrary to the naming of the high position, the range of the piano also needs to be recorded. For example, on Rymu's keyboard, the lowest note is 21. The highest note is 108. It's not 108, it should be 107. It is the same setting in the UE. The lowest note is 21. The highest note is 107. With this information, software can calculate the location of each keys. Okay, so these are the three things that custom characters actually do. The entire runtime workflow is MIDI data entry first, and then the music though, based on the geometry of the instrument and the reference poses, calculate the position and orientation of the controls in each frame. Next, the control information is passed to the control system. Inside the UE is the control rig. In Blender, there are constraints solved by IK. Ultimately drive the character's skeleton. Make the correct playing movements. After these three things are complete, the whole process runs. So that's essentially what the custom character does. Then in the next few episodes, I'll be in Unreal and Blender, respectively, demonstrate these three types of work step by step. Although the two software are different, the logic is exactly the same. And these videos, I will also mark which videos belong to UE, which videos belong to Blender, then which videos are general purpose videos you can choose to watch. After understanding everything that has been said today, you don't have to blindly follow me. You can know exactly what problem we're solving at each step. Okay, this is the end of this issue. Thank you for watching. See you next time.